In this video, we're going to be looking at using the formula to find conditional probability. So we can rewrite the probability of dependence events formula to find the conditional probability. So for events A and B, we have the probability of B given A is equal to the probability of A and B over the probability of A. And so how I did that was, we learned in our last lesson that with dependent events, probability of A times probability of B given A is equal to the probability of A and B. So solving for probability of being given A, I can just divide both sides by probability of A, and that's how I get this formula. So looking at this first example, I'm given that probability of A is equal to 0.75 and probability of A and B is equal to 0.42. Find the probability of B given A. Well, I know from what we just talked about that my formula is that the probability of B given A is equal to the probability of A and B divided by the probability of A. And now I'm going to plug in what I know. I know that probability of A is 0.75, and I know probability of A and B is 0.42. And so this becomes 0.42 over 0.75. And now I just need to divide those. So when I do 0.42 divided by 0.75, I get that the probability of B given A is equal to 0.56. Okay, now number 2 looks a little bit different. This time it says probability of B given A is equal to 0.32 and probability of A and B is equal to 0.14. Find probability of A. So this time we're finding the probability of A. I'm still going to use my formula that we have above. But now my numbers are going to be plugged in elsewhere. So I have probability of B given A is 0.32. So I'm going to replace probability of B given A with 0.32. And I know probability of A and B is 0.14. And now I need to solve this equation for probability of A. One way you can do this is to cross multiply. So what I'm going to do is I'm going to put this 0.32 over 1. And I'm going to do my cross multiplication. So I'm going to do 0.32 times probability of A is equal to 1 times 0.14, which is just 0.14. And then I'm going to solve this for probability of A. So I have this 0.32 being multiplied out in front. So to undo that multiplication, I'm just going to divide both sides by 0.32. And so I do 0.14 divided by 0.32, and I get 0.4375. Okay, let's look at some real-world problems now. So number 3 says, at a school, 60% of students buy a school lunch. Only 10% of students buy lunch and dessert. What is the probability that a student who buys lunch also buys dessert? So let's look at what our events here. So we have event A is that a student buys a school lunch. So we have A equals buys lunch. Second probability is that students buy lunch and dessert. So a second event that I see there is buys dessert. And so I want to find the conditional probability that a student who buys lunch also buys dessert. And so another way I can think of that is that what is the probability a student buys dessert given that they bought lunch? And so we can use our formula for this. And we can use that formula because we're already given 2 other probabilities here. I see in this first part that there is that 60% of students buy a school lunch. So that means that the probability of A is 60%. But if I write that in terms of decimals, that means that probability of A is 0.6. I also have the probability that 10% of students buy lunch and dessert. So the probability of A and B is equal to 0.1. So that's just the 10%. I move that decimal place 2 to the left to get 0.1. So using those values, I can go ahead and find my conditional probability. So the conditional probability B given A is equal to the probability of A and B divided by the probability of A. So I get 0.1 divided by 0.6, which is approximately 0.167. So that means that the probability a student who buys lunch also buys dessert is about 16.7%. Okay, let's look at one more. So this one says, at a coffee shop, 80% of customers order coffee. Only 15% of those customers order coffee and a bagel. What is the probability that a customer who orders coffee also orders a bagel? So again, we're looking at conditional probability because we can restate that last sentence to say, what is the probability that a customer orders a bagel given that they ordered coffee? So we're looking at two different events here. Our first event, A, is that the customer ordered coffee. And then our second event, B, is that they ordered a bagel. And we're given two different probabilities here. We're first given the probability of A, so that 80% of customers order coffee. So that means that the probability of A is equal to 0.8. So again, we change that percentage into a decimal. And then we're also given the event of A and B, and that's because it says that 50% of customers order coffee and bagel. So the probability of A and B is equal to 0.15. And so now I can use that information to find my conditional probability that's asking. So find the probability that a customer orders a bagel given that they ordered a coffee is going to be the probability that they order both divided by the probability of just ordering the coffee. And so that's going to be 0.15 divided by 0.8. And so when I put that into my calculator, I get that this is approximately 0.188. So there is an 18.8% chance.